Continuing chapter 7 on prokaryotes. If you can't quite make out the word bubble, it says, no wonder today's results have been so poor. This isn't growth serum, it's hand sanitizer. I thought that was appropriate to the world that we live in. I mean, how often do you hear a hand sanitizer joke when people are actually talking about hand sanitizer? On from Coke to cone. Cone was the first to, or at least he's the first that gets the credit. There are times where you can't get stuff to culture properly. And you also can't sterilize things the way that they should be sterilized. They don't want to sterilize. What Cone discovered was now, one of the things that happens with some cultures is that if the culture gets a little old and the nutrients get depleted, if you sample it and look at it under the microscope, all the bacteria don't look the same. Not always true, but in some cases it's a mixture. And people are like, okay, we must have a contaminant. Well, no, some of the bacteria have sealed themselves up into a dormant state where they can last for a while. Very many bacteria can fly through the air and get to some place where there's new nutrients that way. And Cone was saying a lot of these spores don't react to sterilization the same way. Is that you use your typical sterilization and you kill the active bacteria, but you don't necessarily kill the spores. And that's why some of the approaches we're using are not particularly effective. Then we get, this is not Cone, this is a little bit later. Antibiotics. Antibio. They knew that bacteria were living things. These were against them, so they called them antibiotics. This is one of those terms that is a little fuzzy in definition. A lot of people, when they talk about antibiotics, they are definitely talking about antibacterials. But you will hear the term antibacterials, which is more specific, because some people go, well, antibiotics is, if it's killing small living things, then, well, you know, protozoa is killing protozoa, it's an antibiotic. I've even heard sometimes people refer to some anti-cancer drugs as antibiotics, although that's a bit of a stretch. But most of the time when people use the term antibiotics, they're talking about antibacterial chemicals that will kill the bacteria in a way that doesn't affect the chemistry of our cells, because there's a bunch of stuff bacteria do that we do not do. Now, this goes back less than 100 years. With the sulfa drugs were some of the first antibiotics. Most of the early antibiotics came from things that had their own reasons for killing bacteria. Other microorganisms that were trying to live off of the same nutrient sources as the bacteria. Molds. Molds and bacteria are both decomposers. They're breaking down organic material. The molds would prefer the bacteria were not chowing down on their food, so they produce a number of chemicals to kill them. Some bacteria do that as well. Some bacteria will try to kill their competitors. They produce something that won't affect them, but will affect the competitors. And as people started to notice what grew and didn't grow, and if your culture got moldy, the bacteria would all die, is that they eventually started to do extracts of these other organisms and check those chemicals for antibacterial qualities. Penicillin from bread molds, particular type of bread mold. Probably not the bread mold growing on your bread right now, but it is from a mold that can grow on bread. And I forget, I think it was Salk that got the Nobel Prize. Somebody got a big prize for discovering penicillin, when there was actually a guy who cleaned the greenhouses, I think, in whatever university in London these guys were working at, who actually came up with a way to produce enough of the mold that you could extract usable, testable amounts of penicillin from it. That was eventually upscaled to produce penicillin on a commercial level. So I don't even know, I suspect he didn't even have a patent on it. I don't know that he ever made any money on it, and he certainly didn't get, he eventually got recognition as people wrote books about it, but I don't think he got much recognition at the time. But that's, you know, that's the way science often works. We are still coasting on antibiotics developed in the 1930s, 1940s, 1950s, some in the 1960s. Not a lot since. Once you've got a bunch of them, even though people get infections all the time, if you're going to develop a new one, here's the problem you wind up with. Through the 60s and 70s, it was discovered that, and even in the 50s, that bacteria, because they are living organisms and they can evolve, that if you keep throwing a certain antibiotic at them, you will eventually encourage the appearance of a resistant strain. A strain whose chemistry is somehow different in a way that penicillin doesn't work on it. And there's a number of different approaches. They may break the penicillin down. Their chemistry that the penicillin is supposed to mess up works a little bit differently, so the penicillin doesn't do that. They take the penicillin and pop it right back out of the cell as soon as it's come into the cell. There's a bunch of different resistance approaches that bacteria use. And so you get people that are resistant. Also, people get allergic to penicillin because it's a big enough molecule, but that's a different issue. So when you get a resistant strain to penicillin, then you go to the cyclins, the tetracyclines and such. And now you're encouraging penicillin-resistant strains for the appearance of tetracycline-resistant strains. But there were a bunch of different antibiotics out there, some of which had somewhat nastier side effects. And so what you wound up with as they encountered resistance was, okay, we're going to develop a new antibiotic. Maybe it's really focused on one particular type of bacterium. Cyclosporins, like if I'm remembering correctly, on UTI bacteria. So it's got a limited application, again, in the world, and you could throw it at multi-antibiotic resistant other bacteria, but you're only going to do that as a last resort. So new antibiotics are kind of in the pocket antibiotics, is that you don't use them widely because you don't want to quickly encourage the appearance of a resistant strain to your new antibiotic. So from a company standpoint, why would you make a new antibiotic? You're not going to sell much of it because people are only going to use it as a last resort in infections. So you're not going to be able to make your development back. It also was getting very tricky, is that the organisms out there weren't given as much in the way of new antibiotics. There was a period of time where we looked into other animals who fight bacteria in a different way than just using the same way we do. Some of them have naturally occurring antibiotics, actual chemicals that circulate in their tissue fluids or their blood that will kill bacteria. Horseshoe crabs. They actually use it for a quick bacterial test if they think you've got a blood infection, because they produce a chemical that will glom bacteria together so that they can't survive. And you can take a mixture of horseshoe crab blood extracted in the lab and mix it with a plasma sample, and if you get clumps, you go, okay, we got bacteria we're dealing with. Now we'll try and figure out what kind of bacteria it is. Certain types of frogs produce their own natural antibiotics. Reptiles do. The problem that wound up happening there is that those antibiotic molecules are fairly large molecules and very prone to people's immune systems recognizing them as an antigen and developing antibodies to it. So people were very quickly developing allergies to these other ones. So there hasn't been a lot of work on new antibiotics. And as the existing bacteria get more and more and more resistant to more and more and more of the antibiotics on the list, some people have projected as early as 10, 15 years in the future that no one's going into a hospital for an elective procedure that is invasive, because your odds of picking up a bad bacterium in a hospital where they've been, that's where they're throwing all the antibiotics and antiseptics at things, is gonna become much more possible, and then they won't have any antibiotics that they can use on it. So unless something changes in the next decade or so, we may see a very different world from what people medically are willing to do. Is it, do you go and get the hip replacement? Do you go and get a facelift? Do you go and have laparoscopic surgery? Do you have a tummy staple? Is that there will be a bunch of things that people do that the risk from the opening of the cavities is going to be too high. It's too big a chance you'll get an infection and die, and people will stop doing it. Okay, I think that is a good place to stop this one, because the next one is a fairly large involved section, and I want to do it as one video.